The numbering system you and I use normally is called the decimal system, as it goes up in multiples of 10. However, as we learnt last lesson, computers use the binary system, where numbers go up in multiples of 2. It's important that when learning binary, we know how to convert numbers between binary and decimal. Let's think about the number 12. It's actually two separate numbers, 1 and 2. However, they belong to different columns. The number 12 can be thought of as 1 10 and 2 ones. In the decimal system, each column goes up in multiples of 10 and can be given a value of 0 to 9, 10 possible values. So if we want to write the number 4096, then we would need to have 4 thousands, 0 hundreds, 9 tens and 6 ones. You're probably very familiar with this entire system from when you were very young. Binary numbers work very similarly, except the columns increase in multiples of 2 and each column can only store a 0 or 1. It's important that you get your columns drawn out first. Remember, the smallest numbers are on the right and the numbers go up by multiples of 2 right to left. The smallest number in a binary sequence is known as the least significant bit. The largest number is known as the most significant bit. So, now we know the difference between decimal and binary, how do we convert a decimal number into a binary number? In order to do this, you need to ask yourself the following question. Can my binary column fit into my decimal number? Let's take a look at the decimal number 25. We are going to convert it into a 6-bit binary number. Firstly, we need to put our binary columns down. As it is going to be 6 bits, we need 6 columns. Now we'll start with the 32 column, our most significant bit. Can 32 fit into 25? No, so we don't have any of these, so we put a 0 in the 32 column. Move on to the 16 column. Can 16 fit into 25? Yes, so we have one of these, so we put 1 in the 16 column. At this point, we need to take the 16 away from 25, which leaves us with 9. Move on to the 8 column. This time we want to know, can 8 fit into 9? Yes, so we have one of these, so we put 1 in the 8 column. Now we have to take 8 away from 9, which leaves us with 1. Move on to the 4 column. Can 4 fit into 1? No, so we don't have one of these, so we put a 0 in the 4 column. Move on to the 2 column. Can 2 fit into 1? No, so we don't have one of these, so we put a 0 in the 2 column. Finally, we move on to the 1 column, our least significant bit. Can 1 fit into 1? Yes, so we have one of these, so we put a 1 in the 1 column. Now we have to take 1 away from 1, which leaves us with 0, and our conversion is now finished. Basically, you need to keep taking away until you reach 0. An important thing to remember is that you must always give your answer in the required number of bits. Your exam will usually want your answer in 8 bits. The number 25 in 8-bit binary is 000111001. Of course, we don't just need to be able to convert decimal numbers into binary numbers, we also need to be able to do the reverse. Let's take the number 25 again. In 6-bit binary, we saw that this is 011001. We'll start by drawing out our columns and putting our binary number into them. To convert this back into decimal, we need to work out which columns have a 1 in them, and then we simply need to add up these column heading values. 16 plus 8 plus 1 equals 25, and that's all it takes. This works for any number, for example 101111010. If we pick all of the 1s and add them up, 128 plus 32 plus 16 plus 8 plus 2 equals 186. So, The decimal number system is based on a counting system where columns go up by multiples of 10. The binary number system is based on a counting system where columns go up by multiples of 2. To convert decimal to binary, keep taking away until you reach 0. To convert binary to decimal, add up all the columns that contain a 1.